Hey guys, welcome back to another A-level maths revision video. In this video today we're going to take a look at some mechanics. And we're going to take a look at pretty much the very end of the textbook here. We're looking at pulleys. So we're looking at the force chapter here. So we're going to be dealing with in this chapter a lot of F equals ma, so the force is equal to the mass times the acceleration. So let's not waste any more time. Let's take a look at the questions we've got in this video. So this first question here, we've got our three particles here. So we've got the particles A, B and C. Now B and C are essentially joined here together. So what I'm essentially going to do here is just kind of think of them as being one particle combined. So for any force question like this, especially for pulleys, what I'm going to do is I'm going to basically do my force diagram here. So let's jot down the weights. So this one here, this weight here, so we've got a mass of 3m, so this will be 3 mg newtons. Here, if it's 2 plus 2, so the sum would be 4, so I've got 4 mg newtons there. With each respective particle here, so if I combine this one here as being 4m, so we'd have a respective tension in the string, so T newtons, and again we'll have T newtons here, and we know the tension is the same because it tells in the question it's a smooth, light, fixed pulley. Okay, so because it's smooth, we know the tensions will be the same. Okay, so the tension is the same, and if we just read the question as well, we know when the system is released from rest, A moves upwards. So if I know the acceleration here, that would be A meters per second, and again here, if A moves upwards, then what we know here is that B will move downwards. Okay, and A meters per second here as well. Okay, the acceleration will be the same for both of them here as well. Okay, and we know that because the string is inextensible. So all we've got to do then is show that the acceleration of A is g over 7. Now, because we're dealing with the acceleration of A, it makes sense to work with particle A. So consider A. So we're going to make use of the fact that the force is equal to the mass times acceleration. So all I'm going to do here is, because motion is going up, so we're going upwards like this, I'm going to resolve in the same direction. Okay, so my force is going up would be T, the tension, minus the weight here, 3 mg. Okay, this is now equal, so that's the force, this is equal to the mass times the acceleration. Well, the mass is 3m and the acceleration is a, so that's 3 ma. Okay, so now what we can do is we can consider B. Well, essentially what we're going to obtain here is simultaneous equations, okay, and then we can solve from there. So if we consider B as well, so consider B, well, because the motion for B is going down, I'm going to resolve in the same direction again. Okay, so that should be down like that. So what would we get when we resolve for B here? Well, it's going to be 4 mg, because we're looking downwards this time, 4 mg minus the tension T, so that's the force, so that's F. This is equal now to the mass times the acceleration. Remember, the mass is the combined, well, it's, it's the mass of the two particles combined, so that's going to be 4m times A, so 4ma. Okay, so at this stage here now, it's up to you how you solve these simultaneous equations, but it shouldn't be too tricky. What I'm going to do is I'm going to rearrange this here in terms of T, so that's 3ma plus 3mg, and then I'm going to substitute that into this equation here. So what I've got here then is 4mg minus 3ma minus 3mg is equal to 4ma. Okay, from here now, it's just a matter of simplifying this till we get to the point where the acceleration is g over 7. So that would be mg here is equal to 7 ma, Have I missed something? Mg is equal to 7 ma. No, that's fine there. Yeah, and then divide through by m here. So we get that g is equal to 7a, and in that case, a is g divided by 7. Okay, just having that linear equation there for a. So that's the first part there, showing that the acceleration of a is g over 7. So if we clear that now, we can just simply work out the tension. In fact, we don't need to clear it. If we do it at the top, we should have enough room. So that was part A. So if I do part B up here then, we want to find the tension in the string as A ascends. So all we need to do here is just sub this acceleration then into either of the equations we've got. Doesn't matter which one you do, it's completely up to you. Seeing as I've rearranged this in terms of the tension here, I'm just going to substitute it into there. So T is equal to 3 ma, but remember A is g over 7, so that's 3m g over 7 plus 3mg. Okay, so this would be 3mg over 7. If you get this in over 7 as well, just add them together, we get the tension then T is 24 over 7 mg newtons there in that case. Okay, so 7 marks that question. The key, or the most important thing with these questions is to do your force diagrams. Make it very clear what you're working with. Make sure you've got all the forces labelled. It's very, very important for these questions. Okay, and we'll see that again with another question. So this question here, quite a lot of marks for this. In total, I think there's 11 in total. Yeah, 11. So let's start step by step. Quite a few different things going on. So part A first then, we want to show that the acceleration of P as it descends is 2.8 ms to the minus 2. Well, don't forget this topic works with SUVAT as well, and SUVAT is very important for all of your mechanics essentially. So with this being acceleration, we can actually use the SUVAT equations here, okay? And the reason we can do that is because we've got some information. Let's just write SUVAT out. So what do we have? Well, we know the height that's given to us, that's 3.15 meters, so that's 3.15. We know U, it starts at rest, so the initial speed is 0. We don't have anything for V. A is what we want to work out. We want to show the acceleration of P is 2.8, so we write that down as what we want to find out. And we know the time. We're told that in the question. It says it's been descending for 1.5 seconds, so that's 1.5 there. Okay, so we've got S, we've got U, we've got A, and we've got T. So look for your formula book now. You're looking for the formula that is in terms of only S, U, A, and T. Okay, and hopefully you pick the right one out. So the formula we're going to use here is S equals UT plus a half AT squared then. Okay, so all I'm going to do now is substitute these values in. So S is 3.15. That's equal to U times T, so that's 0 times 1.5, which is just clearly 0. This is equal to a half of the acceleration, which we don't know, we'll just call it A, times T squared, which is 1.5, so times 1.5 squared. And then at this stage here, it's just a matter of solving this in terms of A to get 2.8. So you can times this 3.15 by 2 if you want, and then divide by the 1.5 squared. So in total, what we get then is A is equal to 6.3 divided by 1.5 squared, which would give us, on your calculator, 2.8 there, okay, with the correct units, which is exactly what we wanted to show. So that's part A done. Nice and easy. Part B then, a little bit more difficult, only because we need to label our diagram. So, like always, let's label our diagram. So, if we write the respective weights here, so this is 0.5 kilograms, so that'd be 0.5 G newtons. This is M, this will be mg newtons. Remember, this is, again, it should be a smooth fixed pulley. So, we've got tensions that we need to write down as well. So that'd be T newtons. And again, the tension here will also be the same, T newtons. Let's also model the motion of the particles. So we know P is descending, so P is descending with acceleration 2.8 for that part. And again, the acceleration will be the same because it's a light inextensible string. So this particle will go up with the same acceleration. Okay. So we want to find the tension in the string as P descends. So I'm just going to resolve here for P. And again, I'm doing it in the way of motion. So as P is descending, I'm going to resolve. Oops, change the pen colour. I'm going to resolve then in the same motion. So what would that give us? Well, that's going to give us 0.5 G minus the tension T. So 0.5 G minus T. That's the force. So now it's equal to mass times acceleration. So we're using F equals ma. So the mass 0.5, and we times it by the acceleration 2.8 here. Okay. So all I need to do now is solve for T. So in that case, T is just simply equal to 0.5 G minus 2.8 times 1.4. Sorry, 2.8 times half, so that's minus 1.4. Getting jumbled with the numbers. And then if you just plug this into your calculator, you'll get 3.5 newtons here for the tension. Okay, so that's part B there. Now that we've got the diagram actually labelled, the questions aren't too bad. For part C, we want to show that M, so that's the mass here of the particle Q, that's 5/18. So let's resolve particle Q then. Again, I'm doing it in the direction of motion, so resolving upwards. So if we resolve this, we know the tension now is 3.5. So if I actually just make a little modification here, we can write our tension as well. So 3.5. Oops, got wrong pen colour. So that's 3.5 newtons. Same here. Okay, so that'll just help us throughout the question. So now we're resolving upwards, so that's going to be 3.5, our tension, minus the force downwards, so mg. This is going to be equal now to mass times acceleration. The mass, we don't know, that's just m, so it's going to be m times by the acceleration, which is 2.8. Okay. Now at this stage here, we just need to solve this in terms of m. Okay, so this will give me 2.8 m here. So we just write it out again. 2.8 m. And then just collect the m's here together, so this would be 9.8 m. So what I get then is 12.6 m is equal to 3.5. So we're solving for m here. We want to show that m is 5/18. So m is 3.5 divided by 12.6, which you can just plug into your calculator and get 5/18. If you weren't doing it with a calculator, which isn't the case, but if you weren't, I times both of them by 10. So 35/126, and then simplify here to be 5/18. Okay, which is exactly what we like to show. Okay, so we know we've got that one correct there. So 4 marks for that. Like you can see, labelling the diagram is really, really important. Okay, so get into a good habit of doing that. You'll find these questions are much, much easier. And then in part D, it asks us to state how we've used the information that the string is inextensible. So remember, when the string is inextensible, what that tells us is the acceleration of P. So the acceleration of P equals the acceleration of Q there. Okay. That's just due to the fact that the string is inextensible. Even if you can't remember that, it's only 1 mark. I wouldn't worry too much. but it's a nice easy mark if you can remember it. Okay, so that's that question done. Now let's take a look at the very last question here. This question is slightly different because if you read the question, the particle A, so let's just change the pen colour so we can start annotating this diagram here. This particle A, it lies on a rough horizontal table. So what that means is we're going to have to deal with friction in this question. Okay, and we can see that in part B, we have to show that mu is equal to 2 over 3. So what I'm going to do here is I'm going to label my diagram. So we start with particle B first. So if we jot the weight down, so that's going to be, so it's the mass is 2m, so that'll be 2 mg newtons. We have the tension in the string, so that'd be T newtons here. And the motion, if we just read the question, yeah, so the motion here is that B descends, so my motion here would be like so. We're told the acceleration is 4 over 9g. 4 over 9g. Okay, so we've got that for this question. Now, if we deal with this particle A here, well, the weight, or the mass here I should say, is m. So the weight here would be mg newtons. We have the opposite force here. We call that Rm. And we also have the tension here in the string. In this case, we have T newtons here again. Smooth pulley, tensions will be the same. So the only other thing we've got left to actually add to the diagram here is the effect of the friction. So as the motion here be this way, friction opposes motion. So the friction will be in this motion here. Okay, so that would be mu n there. So I think we've got everything there. Again, don't forget your acceleration, 4 over 9 g for the acceleration then. So in that case, I think we've got everything here. Let's have a go at tackling it. So let's just change the pen colour. So part A then, we want to find the tension in the string immediately after the particle begins to move. So let's consider B then. Okay, we don't have to deal with the effects of friction. So if we consider B, motion's going down, it descends, the particle descends. So in that case, I'm resolving downwards like so. So in that case, the weight would be 2 mg minus the tension T. That's going to be equal then, so using F equals ma is equal to the mass, which is 2m, times the acceleration, which is 4 over 9 g. Okay, so again, we want to find the tension, so this is just a matter of solving here in terms of T. So if I rearrange this, T is equal then to am over 9 times g. So, but what I'm going to do is I'm going to subtract this. So if I want to make T positive here, we're solving in terms of T. So I'm going to take this T across and take all of this to this side. So that means 2 mg minus this product here. So that would be a over 9 mg. I think that's a nicer way to write it there. Okay. Now notice, if I get this 2 mg here over this denominator of 9, we can just write this as a fraction here in its exact form. So that would be 18 over 9 mg minus 8 over 9 mg. So in that case, the tension then, T, is equal to 10 over 9 mg there. Okay, but I mean tension is in terms of the units there of newtons. So that's part A, 3 marks for that, that's not too bad. Part B then, again, it's not too bad, a little bit trickier, but let's click just so we've got enough room for it. Oh no, I've lost all my files, did that work clever? So I'm going to have to jot them in again, so that's annoying. So that'll teach me. So we did have them all down, so that was mg, newtons. We had the reaction force there. We had a tension here. And we had the effects of friction here. Okay, we also had motion in this direction. and we shouldn't need particle B for this, so we should be okay. Part B then, we want to show that mu, the coefficient of friction here, is equal to 2/3. Well, we're considering A in this case, so consider A. I think it's important as well just to let the examiner know which particle we're considering. Now obviously, I cleared all of my force diagrams here, so the fact that I've only annotated A again means we're obviously going to consider A. But always do it in your exam, make it clear which particle you're considering. So first, let's deal with the vertical forces here. So if we resolve upwards, what will we get? Well, we'd get R minus mg. And this will just be equal to 0, because we don't need to take into account the tension here and the coefficient of friction as they're perpendicular, okay? So we're just going to get here that R is equal to mg, okay? Now, let's resolve in the direction of motion, like so. So, what would I actually get here? Well, we know the tension, so I can actually update my diagram again. So we know the tension, as we worked out, is 10/9 mg newtons for the tension. Okay, so we can use that fact when we're resolving here. So that's going to be 10/9 mg minus the opposite direction here, so minus mu. So this would be mu r, but we know r is mg, so that's minus mu mg. So this is the force. This is now equal to mass times acceleration. So that's going to be equal to the mass, which is m, times the acceleration, which is 4/9 g. Okay. So there's actually a lot of simple cancelling we can do here, basically. I can get rid of an m. Each term involves m, so we can divide by m, like so. And each term actually involves g, so we can divide through by g as well. Okay, so what do I get left with from here then? Well, we've got the 10/9 here. We've got minus mu, and this is equal to 4/9. If I solve for mu here then, because we want to show that mu is 2/3, so mu, take that mu across here and subtract 4/9 off both sides. So 10/9 minus 4/9, that gives us mu being equal to 6/9, and if we cancel down here, we get 2/3 as required. Okay, and there we have it. So there we go, that brings us to the end here, and the end of this video. I hope this has helped. It's definitely one of the tricky topics in mechanics, and it starts basically preparing you for a lot of the second year material. If it's helped, be sure to leave a like, subscribe, all that good stuff. And if there's any issues, again, just leave a comment down below. Cheers.